and then share my screen. All right, so today we're going to be playing in section 5.4, and it deals with what we call complex rational expressions. And rational expressions just means they're fractional looking, okay? So there's a big formula we're wanting to play with today, and it's called the difference quotient. So the difference quotient. So they use this a lot in calculus to find slopes of curvy lines. So this formula is given by f of x plus h minus f of x all over h. Okay. So this is basically just a fancy slope formula, okay? So I won't get into a lot of details. We just want to learn how to work it here. If you take calculus or business calculus, they will explain how they come up with this formula and everything, okay? So to work this, the first thing we got to do is find f of x plus h. Once I found what f of x plus h is, I'm going to plug everything into the formula. All right, after I plug everything in the formula, I'm going to work the top where they're doing the subtraction. So I'm going to perform the subtraction on top. Now, here's what's nice about this formula. When you perform the subtraction, everything in the second parentheses will cancel with the like terms in the first. So everything in second parenthesis will cancel, okay, with the same terms in the first parenthesis. So basically, after this step, if it doesn't have an H in it on the top, it's going to cancel out. And y'all, then the last step is to simplify each term on top by removing one H from all terms. And that basically that's the last step, is to divide all the H's out, because you're going to have H's on top. And since this whole formula is being divided by H, we got to simplify them out at the end, okay? So really the trick on this formula is finding the f of x plus h part of it. So some of these get pretty tricky on the foiling. So I'm gonna let y'all catch up real quick and then I'll turn over. Now what's nice is you don't have to memorize this formula. It's given to you on all the problems, okay? All right, so we're going to work some of these. So my example for the function f of x equals 2x minus 5, we're going to construct and simplify the difference quotient. And they'll give it to us. It's f of x plus h minus f of x all over h. So what's nice is this f of x part right here, we've already got it because they're giving us the f of x. What we got to find is f of x plus h. So the first thing I'm going to do is find my f of x plus h. So remember, f of x plus h means to take this f of x function and wherever they have an x, we got to replace that x with an x plus h. So f of x plus h will equal 2 times x, which is x plus h, and then we have a minus 5. So you take your original function and put that x plus h in for the x. Now, you want to simplify this by removing parentheses. So I would remove these parentheses by distributing my 2. So 2 times x is 2x, plus 2 times h is a positive 2h, and at the end is a minus 5. So I cannot simplify this anymore, so I'm going to put everything now into the formula because I know f of x plus h, I know f of x, and I'm going to divide that all by the h. So y'all, what I usually do when I start this is replace the 2 things on top with parentheses. And then I'll put all that over my h. So this will be f of x plus h minus my f of x they gave me divided by h. So f of x plus h we said was 2x plus 2h minus 5. F of x they gave us was a 2x minus 5. All that's over to h. So if you wanted to rewrite this, you could by distributing the subtraction. So notice the first parenthesis will come down, 2x plus 2h minus 5. Then I get a negative times a positive makes that a negative 2x. And then a negative times a negative makes that a positive 5. All of that is over to h still. Now remember, at this point we said we're going to perform these operations. So everything in the second parenthesis here will now cancel with what was in the first parenthesis. Y'all see that negative 2x? That negative 2x will cancel with that positive 2x. So the x's cancel. Also, if you notice, this positive 5 will cancel with that negative 5. So all that's left is a 2h on the top and the h on the bottom. So y'all, that's what I was talking about. Everything in this second parenthesis here is always going to cancel with what's in the first parenthesis. All that's going to be left in this formula are the h terms, okay? Now your last step is to cancel the h's, and that just leaves me a final answer of 2. But y'all know that if this was y equals mx plus b form of a line, the slope of this line would be the number in front of the x, which was a 2. So right here would be my final answer. So we'll start out sort of mellow on these, and then they'll pick up steam as we go. So let me let y'all finish that up. So basically, if you notice what I could have done, once I found the f of x plus h, cancel everything out that don't have an h, because that's all that's going to be left when we get down to there, okay? All right, y'all, next example. This time we're giving us f of x equals 10x plus 6. So we're going to find, we're going to construct and simplify the difference quotient. All right, so once again, we know it's going to be f of x plus h minus f of x all over h. So once again, the first thing I want to do is find f of x plus h. So that's going to take this f of x and replace that x with an x plus h. So I'll have 10 times x plus h plus 6. And y'all, once again, I'm going to distribute to get rid of parentheses. So 10 times x is 10x plus 10 times h is 10h plus my 6. And if you notice, those are no more like terms than this, so that's as far as I can go. So I'm going to put everything in parentheses, f of x plus h minus f of x all over h. All right, so let's bring the f of x plus h. We said that was 10x plus 10h plus 6. F of x they gave me, that was 10x plus 6. Now, y'all, I'll show y'all, if you don't want to have to rewrite this every time, since these are being subtracted, you got a negative 10x that cancels with a positive 10x. That's going to make that a negative 6. That's going to cancel with a positive 6. So remember, everything in that second parentheses will always cancel. So what's left? All that's left on top is a 10h over h. And notice that last step said cancel all the h's on top with what's on bottom. So that 1h cancels with that 1h. So my final answer again is 10. But straight lines aren't bad because we know the slope on a straight line is the number in front of the x. So that's why that matched out. But y'all, we're about to start doing curvy lines, and you just can't pick the number in front of the x when you got curvy lines, okay? All right, y'all good on that? All right, so we're going to turn it up now. So this next one, we're given f of x is going to equal x squared minus 4. So once again, we're going to construct and simplify the difference quotient. Difference quotient. F of x plus h minus f of x all over h. All right, y'all, so watch this one. It's a little bit trickier because I got that square term up there. So the first thing I'm going to do, I'm going to find f of x plus h. So that means replace this x with x plus h. So I'm going to have an x plus h squared minus 4. So y'all remember, x plus h squared, you cannot just distribute the exponent and make that an x squared plus a h squared. You gotta write that twice and FOIL it. So I'm gonna FOIL the first part and just bring down that -4 as I go. So FOILing this, we got x times x is a x squared. X times h is a hx. So I'm just putting them in alphabetical order. H times x is another hx. And then h times h is a h squared. And at the end, I still got my -4. So let's add like terms. This x squared comes down. Hx plus hx is a 2hx plus the h squared and then the -4. So remember, when you add like terms, do not change the exponents, okay? All right, we cannot go any further for this. So this part is now my f of x plus h. So I'm going to have f of x plus h minus f of x all over my h. All right, y'all, so plug this in. Here's the x squared plus 2hx plus h squared minus 4. F of x they gave me was a x squared minus 4. All right, so let's see if this works. You got a negative x squared over here, positive x squared. The x squareds are going to cancel. A double negative makes that a +4, and that +4 will now cancel with that -4. So you can go through every time and pretty much cancel out that second parenthesis. Now, only h terms are left. I got a 2hx plus a h squared all over h. So what you would do to this part, you would treat this like 2hx is being divided by the h. You would also divide the h squared by the h. Everything on top has to divide by that h. So y'all, the 2hx, when you divide it by the h cancels, and all you're left with is a 2x. Over here, you got an h squared divided by that h. So what you would do was subtract exponents. 2 minus 1 would leave you 1h. And you could have done that here. 1 minus 1 was 0, so those h's canceled. And then 2 minus 1 left 1h there. And y'all, nothing else you can do to that. So that would be your final answer. So what this means is when you got a curvy line, it depends where the x is in order to find the slope. So y'all, one thing you can remember, x plus h squared will always equal x squared plus 2hx plus the h squared part. So save that because we might need that later, okay? All right, so let me let y'all catch up on that one. All right, and the next one's going to be a little trickier than this one. They keep adding up as we go. All right, y'all, so here we go. F of x is going to equal -6x squared plus 3x plus 10. So once again, we're going to construct and simplify the difference quotient. f of x plus h minus f of x all over h. Hey, is any of y'all doing business calculus? Because if you're doing business calculus, you want to know this formula. All right, so the first thing we got to do is find f of x plus h. Now notice f of x has two x's in it, so both of them x's have to be replaced with the x plus h. So you'll have negative 6 times x plus h squared plus 3 times x plus h plus 10. So you still got negative 6x squared plus a 3x plus 10. Now, we know what x plus h squared is because we just did that on the last problem. So the x plus h squared gave us an x squared plus 2hx plus h squared. So y'all, since you foiled that on the last problem, just bring it down, okay? And then I'm going to bring down the 3 times the x plus h plus my 10. So now what I would do is distribute the negative 6 through the first parentheses and the positive 3 through the second parentheses. So negative 6 times x squared is a negative 6x squared. Negative 6 times 2 is a negative 12hx. Negative 6 times h squared is a negative 6h squared. Then I got 3 times x is a 3x. 3 times h is a 3h. And then at the end is my positive 10. Y'all look at this. Sadly, there are no like terms in here. So this whole thing is now f of x plus h. So we'll take that minus the f of x. All of that will be over h. All right, so let me fit all this in here. Negative 6x squared minus 12hx minus 6h squared plus 3x plus 3h plus 10. So notice that got sort of long, but it's because I had so many x's up here, okay? F of x was a negative 6x squared plus 3x plus 10, and then I got my h on the bottom. So remember, this negative times a negative makes that a positive 6x squared. That's going to cancel with the negative 6x squared. 3x, that's going to make that a negative 3x. So the 3x cancels with the positive 3x. And then that negative is going to make that 10 negative. And that negative 10 will cancel with that positive 10. So no matter how long these get, everything in that second parenthesis is still going to cancel. So y'all, let's see what's left. We got a negative 12hx minus 6h squared plus 3h all over h. So now, since you got 3 parts on top, all 3 parts have to divide by the h. So when you divide the negative 12hx by the h, it cancels, and you end up with a negative 12x minus 6h squared over h. One of these h's will cancel, leaving me 1. So that's going to minus 6h. So basically, you're just taking away 1h on the top. And then you got a 3h divided by h. H's cancel. All that's left is 3. And y'all, none of these are like terms. So that would be my final answer. So welcome to calculus, right? All right, y'all, so one more of these, and you know we save the best for last. Given f of x equals 3x to the third, construct and simplify the difference quotient. So f of x plus h minus f of x all divided by RH. So the first thing we got to find is f of x plus h. So that means replace this x with x plus h. So we'll have 3 times x plus h to the third power. So let's do a little side work on this one. My side work is going to be this x plus h to the third. That means we have to write this 3 times and FOIL it. So what I'm going to do is FOIL these two first because I know what they make. So I'm going to bring down the first x plus h. We have done FOILed this. This is the third time we FOILed it, so that we should get an x squared plus 2hx plus h squared. So now if you wanted to, you could FOIL that and do x times x and so on, okay? Add like terms and you'll still get this. Now, I got to take these two terms and multiply by all of these. So the x times x squared will be an x to the third. X times 2hx is a 2hx squared. So I added 1 and 1 and got 2 on those. X times h squared is just a h squared x. So I'm just putting them in alphabetical order. Now watch this. H times x squared is a h x squared. H times 2hx is a 2h squared x. And then finally, h times h squared is a h to the third. So y'all watch in here. Hx squared will add to that hx squared. And then this h squared x will add to that h squared x. So let me pull this over. Y'all ain't seeing that exponent of 3. Put that 3 there. So then I would bring down the x to the third. 2 plus 1 gives me 3hx squareds. 1 plus 2 give me 3h squared x's. So notice on like terms, the exponents and the variables have to match exactly. And then at the end is my plus h to the third. So what I can do now finally is plug all this in for that. So I got 3 times x to the third plus 3hx squared plus 3h squared x plus h to the third. Y'all, what's sad is we're doing all this work just to find the f of x plus h. So finally, f of x plus h, I will distribute that 3 through these parentheses. 3 times x cubed is a 3x cubed 3 times 3 gives me 9hx squared. 3 times 3 give me 9h squared x's. And then 3 times h to the cube is a 3h to the third. That is now finally f of x plus h. So you don't like them when you got 3's out here and high exponents, but y'all get good at foiling because I think it's section 8.3 later or 8.4. We do a lot of foiling, okay? All right, so now we want to do f of x plus h minus f of x all over h. So let me put in my 3x to the third plus my 9hx squared plus 9h squared x plus my 3h to the third. The only thing that f of x is a 3x to the third. But y'all, we knew that because all these terms with the h's are not going to cancel. It's just the terms without the h's. So that this negative 3x to the third cancels with that positive 3x to the third. So what's left will be 9hx squared plus 9h squared x plus 3h to the third all over h. So you got 3 parts on the top. All of them have an h. We now have to divide everybody by 1h. So this 1h cancels. I'm left with a 9x squared. 1h in the middle cancels, leaving me with a positive 9hx. So cancel one of those h's. And then here you had 3h to the third. 3 minus 1 will leave you 2 h's. So that'll be a 3h to the second. And then we'd be done. So these points, when they got x's left in them, it depends where those x values are to find the slopes, okay? Because those curvy lines, notice some sides go up, some sides go down. So they're looking at the slopes at each one of these little x points on here, okay? And that'll determine. So like I said, business calculus gets to play with this formula a whole lot. And then probably Cal 1, you would do that if you're taking them kind of classes. All right, but in the long run, that difference quotient is nothing but a fancy slope formula. All right, so y'all, any questions on these?
No.
All right, so let me stop my share. All right, so I'm gonna stop that video.